Hello friends, welcome to Derek Marina YouTube channel. Today we will be discussing about how does a brushless alternator working. So let's move on to the topic. Brushless alternator are used because mainly there is less wear, tear on the alternator because there are only a very few moving parts also. So we are using brushless alternator because of this. And in brushless alternator, slip rings and brushes are eliminated. So and excitation is provided not only by conventional direct current excitation but by a small exciter also. That means by a small alternator also. And operation principle of brushless alternator. In alternators, alternate voltage may be generated by rotating a coil wire in a magnetic field or rotating magnet field in a stationary coil wire. It doesn't matter whether the coil is moving or magnetic field is moving. Either configurations work equally well and both are good and both can be used in a combination depending upon the mechanical and electrical and depend upon the objectives. But in the case of brushless alternator, we can use both combinations are used together in one machine. Before going to the explanation part, we should know some basics. Means to know revise what is stator, rotor, field windings, armature and all. Then we will have much clear idea about it. Stator means the stationary part of an alternator. The rotating part is known as rotor. Coils of wire used to produce a magnetic field are called field windings. And coils that power are called armature winding. In this brushless alternator, you can see both armature and field windings used as well as rotor as well as stator. Depend upon the situation. We will be seeing understand much more in the further topics, further session. Working of a brushless alternator. The brushless alternator have mainly two parts. Mainly two parts means one is excitation alternator part and other is main alternator part. Here in this picture we can see brushless alternator. We can see exciter armature. That means exciter field will be there. In between there will be diode mounting plate. That is mainly for automatic voltage regulator. Then main alternator side there will be main armature field and all. So excitation armature. In excitation armature, here armature is rotor and exciter field winding is stator. Armature rotor, field winding stator. The exciter field produces a magnetic field by help of automatic voltage regulator or residual magnetism. When it starts rotating, voltage is generated in exciter armature which gives current to the main field to produce magnetic field in the main alternator. Means in excitation alternator, armature is rotor, exciter field winding is stator. This exciter field winding produces magnetic field by the help of automatic voltage regulator or residual magnetism. When it starts rotating, voltage will be generated in the exciter armature which gives current to the main field to produce magnetic field in the main alternator. In the main alternator, it will be reverse like this. Main field will be a rotor, armature is stator. So voltage produced in the exciter armature pass through the diode mounting plate, that is rectifier, and goes to the main field which will produce a magnetic field. Means voltage that is produced in the exciter armature pass through the diode and goes to the main field which produces a magnetic field across this. When this magnetic field cuts the main armature, a potential difference or voltage will be produced. And we can take supply out directly and no brushes near it. Here the voltage produced can be regulated by the exciter field current, mainly with the help of automatic voltage regulator. Automatic voltage regulator. Here automatic voltage regulator controls the output voltage by controlling the exciter field current. By controlling the output exciter field current, it is controlling the voltage, output voltage. It sends the output voltage from main armature, compares it with the set value and then changes the exciter field current. This automatic voltage regulator having have diodes. Like I mentioned in the picture we can see they have which can convert AC current into DC for the exciter field. Here we can see a picture of a circuit diagram of a three-phase brushless alternator. Exciter armature will be there, main field will be there, stator, rotor and all. This can be as it composed of two alternator connect end to end on a single shaft. Like I mentioned, main alternator and so small alternator. That's exciter alternator. This large main alternator has armature is stationary, magnetic field is rotating. Its smaller field winding is stationary, armature is rotating. So AC output from the exciter armature is given to the three-phase diode bridge circuit mounted on the extender shaft of the main alternator to produce steady DC voltage. Means AC output from the excitation alternator is given to the three-phase diode from the bridge circuit mounted into it. Through the shaft it will go to main alternator, and from there it produces output voltage which steadily converted into steady DC voltage. Here we can see the field windings, armature winding. From the armature winding we can see AVR means automatic voltage regulator field winding. Then here the diodes we can see diode bridge circuit, the main field winding, Zener diode Z1 Z2. Then means R means here suppression resistance and all. So the DC voltage is directly to the field coil of the main alternator, which is located on the rotor. With this arrangement, there will be carbon brushes and slip switches are eliminated. Like I mentioned above in the earlier, means brushless alternator we have the use of carbon brushes and slip rings are eliminated. Because of the absence of these brushes or brush gears, the carbon dust deposit will be less. So it will be reliability will be high and considerably reduce the our generator maintenance will be less, and power loss is also reduced due to rectification of AC exciter voltage is achieved by 6 shaft mounted on the silicon diodes. The suppression resistor control across the main generator field protect the diodes against voltage surge rising from sudden change in the excitation current. Means here there is, like I mentioned, the suppression resistance is provided across the main generator. It will protect the diode against sudden voltage surge due to sudden change in excitation. Prevent the sudden voltage surge due to surge arising from sudden change in excitation current. Thank you.